Hello everybody. So over the last few weeks I have been learning a lot about Rust, and I'm quite enjoying it. I've been excited to learn it for quite a long time, and I finally got a chance that I can sit down and play with it. And it's been a struggle. I've had to work through a lot of things. Coming from Go, it's like the opposite language of Go. Abstractions for everything and really just get you in down at the bottom. And the learning curve has been steep, but I don't think I'm the first person to say that. Still, I managed to make some sense of it, and I thought I'd take you through some of the things that I have been learning as I've worked them out. So my first project in Rust has been to port a library that I've already got working in Go, and I use it in almost all of my Go projects now. Basically, it combines flags in a config file to give you flags first, but if there aren't a flag, it'll go to the config or then a default if that's not been given. And so now I'm going to kind of try and repeat my learning experience through making the library again. So we'll start here with cargo new, and we'll call it lazyf2 because I've already done it as lazyf before. And we've got the source folder, so we'll go into the source, and we can open up lib.rs, and it's just got some basic tests in which we can run, but helpful to have those as well for just being able to compile, but we'll tweak those in a bit. And so we had a public function for flags. We'll call it get flag. And this would take the name of the flag, and that would be a pointer to string or a borrowed string, and it will return an actual string. Now, string and pointers to and str are a little bit weird. As far as I can tell, your string is like the concrete string type, and the and string is a pointer. If ever you write a string literal, that will be a pointer to string, but you can actually convert that to a full-on string. And because a str is borrowed, it's very difficult to return an and string directly. So in general, I found it easiest to receive an and string and return a full string, because that will be moved directly along with the rules of the borrow checker. That seems to make sense. And you can't borrow something that belongs to a function that's about to end. That took some getting my head around. The thing we needed to use to actually get the environment variables was standard.env. So in principle, all we need to do is loop through env args, and that's an I in, or we'll call it A for arg. And then all we'll do is if A is equal to fname, then, well, we can't return it directly because that would just be a yes. We actually want the thing after it, don't we? So let's mark found to true, and we'll found equals false. So the mut here means it's mutable, and that basically means you can change it in the code. If you don't put that, you can't change it. It's just a little bit of extra safety. Very useful when you send stuff to functions to know whether it's going to be a mutable thing or not. And if found is true, we can return A. So we'll always get the one directly after the thing, and we'll need to put to string on here. And if we've made it all the way through the arguments, if found, then we should return, I'll leave it empty for now. And what do we do if we've not found it? Now we're going to switch this to an option type, not a result, because an option gives you some, in which case there's something in it, or none, in which case there's nothing to look at. So if we go with an option, and that can either be, if it is an option, it will be a string, and if it's not, then it will just be a none. And these options are basically enums, which are crazy cool things. I really like Rust's enums. We'll try and talk about those a bit later, certainly when we run the test on this flag. So we can no longer return A to string. We now need to return sum, which is in the global scope for reasons that make it much more practical. And here we will return a sum, as in it was found, but it's empty. And lastly, we can return none. Now the problem I had here was, how on earth do I write a test for this? Because getting an iterator, what can I do to make an iterator that actually works as I need to be able to run these tests? In the end, I broke this apart to make testing slightly simpler, and I created an object which also had the other advantage of being able to start using traits, but I'll come to where I got to that later. So we'll create two objects here. We'll have a pub struct, and we'll call it fg, and this won't actually store anything. It's just gonna act on our behalf. And we'll have another public struct called fg test, and this one will need something because it will need the vector it's going to work with, the array we're going to work with for creating the iterator. So we'll call it v, and we'll make it a vector of string. And now for these we can actually implement the method. So we'll impl on fg, and we'll write our method, and we'll just call it get. Let's call it getS because this is where I ended up calling it in the end, and it works. And again, this takes a flag name, and it will return an option, which is a string. Now in order for this to be able to call the other function that we want to be able to test, I'm going to need to change it to also take something else, and we'll take an iterator. Now this took me ages to get right, but it's iter, I'll call it that. An iterator, which is quite a generic type in Rust because all of your for loops are dependent on iterators. And we say item equals string, which is an odd notation that kind of fits when you actually create structs. You can actually create type requirements and put that in the implementation and use them throughout. And this actually needs to be mutable because we're going to ask for something and then ask for something again, and it's got to know to move. So it needs to be mutable. And then of course in this function, instead of going through env.args, we're going to go through iter. And our normal fg can now just return, and we don't even need to write return. If it's a single statement, this kind of works. Right, get flag, and we can just pass fname directly, and the iter will be and mutable on env.args. And I'm going to continue to say dot even though I mean colon colon for brain reasons. And that should work. The challenge comes for the fg test. These should of course take a self parameter, which I had forgotten about. As soon as you're implementing, unless it's creating a new one, it's a static method, it should take a self. And you want to borrow it because you don't want to consume it as soon as someone uses it. So that's why we put and self. And by consume, I mean that if you don't put an and someone calls a function, well, self is put into this scope, and so at the end of the scope it will be destroyed. And we don't want that. We want people to carry on using it afterwards, and so we just borrow it and we give it back to the one who created it. I tell you, borrowing has taken me ages to get my head around, but I think I'm almost close to getting it. It probably goes a lot deeper than I really understand, honestly. But progress, right? Let's carry on. We'll give this exactly the same method, and that's an and self and fname and string. And this will also return an option and a string. And we need to call get flag, but the question is, what do we call get flag with? So we'll call get flag, and it's fname, obviously. Now this was the challenge. And now you think you want to write, oh well, okay, .v, and you find out the method is into iter, And v is of course belonging to self, so we have to put self.v.intoIter, and that should work. And you don't put a semicolon on if you're just returning it directly, because it should be the last thing in the scope anyway. You feel like this should work, but when we run it, you'll see the borrow checker will come up with a problem. So let's write a quick test. So function find flag, and we'll call this, it won't take any parameters because tests don't need to. And we'll make a vector, and we'll go let a equals vec, and then you put a thing because it's actually a macro. I don't think I'm going to have time to cover macros in this, but basically they just get replaced with a bit of fancy code to do the same job. And we'll put dash a, and we'll write to string here, and then hello, and again to string, because otherwise it will be a vector of and str, which isn't quite what we want. We can make an fg with that vector. Let's go let ft equal, and this is an fg test, and we'll set its v to, and then let's test the get flag. So if we do assert equal ft dot get s on, and we'll look for dash a, and we want to compare if that is equal to the word hello. Now I don't think this is going to compile, and I think the reason it will fail is at this method where we lose access to v and we can no longer access it again afterwards. We'll see. And if I type cargo test, we'll find out all the problems. Many problems. So of course you need to write fn in front of your functions. And because the test is actually a different module, you're going to need to use an fg test. So we'll use fg test. Of course this should be a sum. Should be fname. And in this return sum it should be a to string. So here it's expecting a mutable reference. We can probably fix this just by typing and mute. Okay, so back to the test. It's not letting me get away with being lazy. I'm going to have to write to string here. Now it's only complaining about the one thing that I was talking about. This cannot move out of borrowed content. So here's the problem that I was really trying to get to. Self.v.intoIter. You cannot move out of borrowed content. And what that's basically saying is that self is borrowed in the function. So if we borrow self, because we can take self, if we accept self as this parameter, this should work. And it passes the test. We got the right result. But then if we try and do this again and try and get another flag, and this should of course return a none, this should complain. And here it's saying used after move. So we've actually moved the value. It is permanently gone into making that iterator. When we called getS, we lost access to ft because it was lost inside the getS method, as it would have been destructed at the end here. So we do need to borrow it if we want to be able to use the iterator more than once. And that caused a problem. And the solution I found in the end was just to clone the vector. Anything that has the clone property can get a copy of itself, and so you don't lose the access to the copy originally had. And with that done, we now only get a couple of warnings from things that aren't used but we will probably use soon. Now the next thing I wanted to do was have a function that could return a default, and that's actually fairly straightforward to write for this. So we can write a function and we add a default parameter, and we don't want to return an option from this, we just want to return a string. And if we were unable to find the flag, we just fill it in with the default value. So here we can write self.getS, oh, and this needs a default, and we just pass it the same parameter as before, and our result will be an option which we can then match. And this is where enums are pretty cool. We can match this against the two types there are, so we can have sum s, in which case we return s. We don't need to write any more than that. The match will be returned as the result of the match is the result of the function. And if we do get a none, then we can just return the default. But this will need to be string. Now the next thing I really wanted was the ability to take these directly and get them as the right type. Now in Go, in the library I have, I've got to get int, I've got to get bool, I've got to get various other kinds that I regularly use. And I started getting ready to write those. I'll write the method as I started writing, so we'll call it this function get s, and I'll call it int. Maybe i32 because that's a type in Rust. And so this will take an and self, and of course it will take the flag name, and this should return an option on, and it will be an i32. And this is where I started, and we'll match self.getS fname, and again we've got a sum and a none. So for the sum with an s, we'll return something, we don't know what yet, and obviously for none we can just return none. So from here I discovered there was a parse method, but in order to use the parse method you needed the from string trait. So I needed to get that into scope. So use, it was standard string, and then it was from string, which is a trait that enables the parse method to work. So then I could do a match on s.parse, and I could specify the type I wanted here, and that was an i32, and then create a new scope for this match. This actually returns a result type, so this can have an error because sometimes you just can't pass an int from a string that includes weird things. So on OK with an n, which will be our number, we get to return sum with n. But if we get an error, and I'm not going to worry about the contents of the error, we will just return none. I'm sure that some of you who are more familiar with generics than I am, I haven't been using generics for a while, will be like, well, clearly there's an obvious thing you can do here. And this is kind of where it clicked. So I called the method getT, and this now take a type parameter, and we'll call it t, and as long as it has a from string method trait, then this will work for anything. And so I can call this t, and suddenly this works for any type that has a from string trait, which is pretty cool, really. And of course that means you could implement your own from strings for something else, and you could just get it off of a flag just directly. And then of course I wrote the default method as well. And for that I was able to say the type was of course type t. And this function will just return an item of type t and not worry about options. And we can instruct this to be the right type. And in this case, if we get sum, then we can return t or none, in which case we return none. And that just made it instantly available to just get anything you want. So, and I was going to put this test here, but of course we can't do that because FGTest doesn't have these new methods that we've just added. And this is, I guess, where for me this whole thing started to grow and it kind of exploded. So I'm going to create a new trait now, and it's going to be called an Sgetter. I'm just going to copy and paste a bunch of code out of here. I'm actually going to cut and paste it because now I don't need it in FG. So we'll get rid of these three and we will put them inside the Sgetter. And it also needs one more function, which is this is a required function, and that's getS, because all of these other functions depend on that. And this takes and self and it returns an option on string. And then we just put a semicolon, and this says this is a required method. And these methods aren't required, but you can actually change them in the trait directly if you want to, but providing defaults means that this is now available for all of them. And instead of this impl for FGTest, we can now write impl Sgetter for FGTest, and it has this method. It fulfills the Sgetter method, and we can do the same for FG. And now we can add that assert method direct here. Assert equal, and we can do ft.getT, and let's do it with a default. Sorry, let's do that on -c, and we'll give it the default of 4. And we can compare and say if that is equal to 4, because if it hasn't worked, we should get the default. Now we'll run the tests. So I've called that the wrong name. It's actually from str. So we'll change them now to from str. Oh yes, and inside the testing module, we need to actually use Sgetter as well as FGTest. Oh, here it is. Haha. Of course, this option shouldn't be I32 now. It should actually be a T. Aha, and we can't return none here. Here we have to return the def. Oh, and this is why we have many testings and stuff. Oh, and I meant to close that, which I think I had before. And with that test, that has worked. Let's actually add another option to this vector. And we'll actually give that a string which looks like a num, so we'll say 34. And now we can do an assert equal on ft.getTdef, and this will be on -f, and its default will be 0, but we are expecting 34, and this should also work. And if we make that a slightly different number, like 5, this should fail, right? The test will fail, and we'll get a result which lets us tell us and says, yeah, we were expecting 34, we got 35. So that's a happy set of tests, but this generic stuff goes deeper. So I also made a method for binding stuff among the config file, and then I made one which combines flags and the config file, which wrap these two. But they needed different names for the flags and the config file. And so the config needed to take 2 parameters to find, but it still just returned a string. And I thought, I wonder if we can still make this work. And the answer is yes, but it was also very tricky. I'm just going to go straight there and show you the answer rather than try and write it again, because that's a lot more code to actually put together. So And if we go into the source, I put the getter method in a different file, so it's called get. And I added a trait to the Sgetter. So this could be anything as the second parameter. Primarily, I wanted it to either be a one thing, like a string, or it could be two strings, like a tuple. And you can do that. I was pretty chuffed. So now it takes a getting parameter of a specific type, but functionally everything still works the same in the trait. Assuming you have a get method which takes this it type, that's input index type, then you will get a result of result type, and you can get the default method as well. And then in the config method, I actually wanted this to provide functions for getting in a slightly different way. So when we implement Sgetter, now this was a thing, this was a fight and a half with the compiler. I have not got my head around lifetime annotations yet, but I'm making some progress. So basically the important thing to note is that if you're taking a borrowed type in as an unknown parameter, you need to be a bit more careful. If you're just taking a fixed type like a string or something that you can move, then lifetimes don't matter so much. But if you're taking a borrowed type, as I was, this tuple, this actually takes a tuple of string and string, both with the lifetime, which I had to assign. Now that's an apostrophe A is creating the lifetime that we're working with, and here we are saying this string will fit to the lifetime of the trait, or of this instance. And so when I wrote the get method, the type it takes is fc, which is a tuple of string and string, and I was able to pull the fg, the flag name, and the config name out of these two things, and then I would look and see if it was in the flag. If it wasn't in the flag, then I would see if I could find it in the list, the config file. And this actually worked. You could, so with the simple acts of making this function, the getS function, like I've done in the flag methods, which also has to implement the lifetimes now, because it's taking a borrowed string. But I was able to implement this for string as before, and the getS works. But on the config side, I'm also able to take a borrowed tuple. And that saving of code repetitions is one of the reasons I think I'm going to stick with Rust for now. I've quite enjoyed learning about this timeline and the generic stuff. I definitely haven't got everything under wraps, but do take a look, do try this. The library is up on Coded Convoy flat lazy FRS, I think it's under, but it's definitely on my GitHub at Coded Convoy, and you can find it there. And feel free to read it and learn and do what you want with it. So I'll see you next time. My name is Matt Stoodley from storyfeet.com, and this has been Fun with Traits in Rust.